Okay, we're heading into chapter 3 now, which is going to be on solving systems of equations and inequalities. We're going to be doing some pretty interesting stuff. Let's begin with, we're just going to be getting some basics down here. We're going to have a couple equations. We're going to graph the two lines, and then we're going to see where they cross. And that's going to represent the solution for the whole entire system, which means the answer works for each and every equation. So, for instance, this first one here, 2x minus 4y equals negative 2 would be a line, and it would be a line that has infinitely many points on it. Well, 3x plus y equals 17 would also be a line that has infinitely many points. The question is, do those two lines cross? And if they do, where is that point that they cross? Because that point where they cross, that's the x and y that would make both true. Now this first one, we're just going to see if 5, 3 happens to work for both. I show you the work down here. I plug 5 and 3 into the equations, and we see that it'd be 10 minus 12 equals negative 2. And that's what we wanted. We wanted to be able to plug in 5 and 3 and get negative 2. But just because it works for the first one doesn't mean it works for the second. Remember, infinitely many points work for either one. So just because I found one to work for the first doesn't mean it works for the entire system. So down here I've plugged in 5 and 3 in for x and y. So instead of 3x plus y, I have 3 times 5 plus 3. That's 15 plus 3, and that's 18. And we want it to be 17. 18 doesn't equal 17, so the point 5, 3 is not a solution. Is that a solution? No, because it only works for one equation, not both. Is 4 and negative 1 a solution to the following system? Again, here we're just testing, we're not doing any graphing. You're going to plug in for x and y, 4 and negative 1. But it was x minus y, so it's 4 minus negative 1. That has to equal 5. Well, that turns into 4 plus 1, which is 5. So it works for the first one. Moving on down, let's plug it in for the second one. You have 4 times 4 instead of 4x plus 3 times negative 1. That would be 16 plus negative 3, and that is 13. That works for both. So is it a solution? Yes. So graph both. How are we going to solve that graph? We're going to graph both lines. And I said use whichever method is easiest. That means if it's in slope-intercept form, use the slope and the y-intercept. If it's in standard form, I would find the two intercepts. After you do that, identify the coordinates where the lines intersect. Plug those in like we did in the previous two problems to make sure that they work. If the lines don't cross, you're going to put no solution. And remember, lines that don't cross would be parallel, but you put no solution. And then if the lines overlap one another, you're going to put infinitely many solutions. Infinitely many solutions, because those lines are said to coincide. Essentially, they're the same line. They're just graphed right on top of each other. So every point that works for the first equation is going to work for the second one. All right, let's get to graphing. Now, when you graph these, it's important that you use a ruler in order to come up with your solutions. We're graphing 2x minus y equals 5. That is in standard form, so I would plug in the zeros. When I plug in x is 0, I get y is negative 5. Divide 5 by negative 1. When y is 0, I got to do 5 divided by 2, and that's 2.5. So I have 0, negative 5, and 2.5, 0. Again, I would use a ruler if I were you. Hard for me to use a ruler on the board here, so I'm going to draw a line and try to manipulate it in a way that it goes through these 2 points. Let's see if I start that there, activate through the point Okay, that's pretty good. Right there. Graphing is not the best method to solve these, but it's important to see how this works. So we do it anyways. This one is also in standard form, so I plug in x is 0, and then I get y is 2.5. And then I would plug in y is 0, which cancels that out, and I get x is 5. So that one's at 5, 0, and 0, 2.5. We'll line through that one. And I don't need to extend that line anymore. What I'm trying to identify is where they cross. And these look like it crosses at a very nice spot. It crosses at 3, 1. X is 3, y is 1. We think x equals 3, and we think y equals 1. Well, now you need to plug that in just to verify that that works for both. So the first equation was 2x minus y is supposed to equal 5. 2x minus y is supposed to equal 5. Well, 2x is 2 times 3, which is 6, and minus 1 is in fact 5. So it works for that one. And then the second one was x plus 2y is supposed to equal 5. So x is 3, y is 1, and I end up with 3 plus 2 is 5. That also works. So those are my answers for the system. 3, 1. 3, 1 is a point on both lines. So that is an answer for the system. So we have another one here for you to practice. Both in standard form. Here, if x is 0, y is negative 2. Negative 8 divided by 4 is negative 2. And down here, if y is 0, x is negative 4. So we have 0, negative 2. We have negative 4, 0. And we'll draw a line through there. Something like that right there. Hopefully that'll work. I might have to extend it out. If I were you, I would take that ruler and extend the line out as far as you can go, just in case the intersection point is not near your x and y intercepts. Okay, this one right here, plugging in x is 0, I get y is 8. Plug in y is 0, and I get x is 8/3, which is 2 2/3, so a little bit under 3. So I'm going to go a little bit under 3, and I'm going to go at 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to draw a line. I'm hoping that these cross in a nice location. Okay, I'm guessing that's what I'm going for. This point right here looks like it would be a nice even point. I'm trying to give you even points for practice. So that would be 4 right, 4 down. That would be x is 4, y is negative 4 for a solution set. Otherwise, you could write x is 4 and y is negative 4. But we still want to check that by plugging it into the initial two equations. Well, the first equation tells me that 2x plus 4y is supposed to be negative 8. So that'd be 2 times 4, which is 8, and 4 times negative 4, which is negative 16. And so far, I'm feeling pretty good about it because 8 plus negative 16 is negative 8. The second one, is 3x plus y. And that's supposed to equal 8. Well, if I put 4 in for x, that's what I think x is, and I put negative 4 in for y, well, that's 12 plus negative 4, and that's 8. So that works. That's my answers right there. X is 4 and y is negative 8. that is our little quick lesson on graphing equations so that you can find a solution that works for an entire system. In this case, our system had two equations. Thanks for watching. Have a great day.